Today we are going to learn the area of triangle, how to find area of triangle using the method of determinant. So in this example, now I have taken the general numbers. Let a x1 y1 is the vertex, b is x2 y2, c is x3 y3. Then area of triangle will be 1 by 2 x1 y1 x1 x2 x3 y1 y2 y3 1 1 1, or this can be written as x1 x2 x2 x1 x2 x3 y1 y2 y3 and 1 1 1. This way also it can be done. So now you see, this is exercise 4.3 question number 2. You have to show that these points are collinear. So how we can show? If we show that the area of this triangle is 0, then automatically the points will become collinear. So I am now finding the area. I am writing here answer. Area will be 1 by 2. x1 is a, x2 is b, and this is c, and this is b plus c, this is c plus a, and this is a plus b, and this is 1 1 1. So now you have this determinant. Now it's up to you how you evaluate it, because using the properties is not compulsory, but it's up to you then how you use it. But if I feel like if I add c2, or if I do c1 tends to c1 plus c2, then it becomes a1 a2 a3. It becomes very easy if apply property. So apply c1 plus c2. So after applying the property c1 plus c2, this becomes this. Then this is b plus c, this is c plus a, this is a plus b, this is 1 1 1. So now you can see this a plus b plus c can be taken out common. So this one becomes 1 1 1, and this is b plus c, this is c plus a, this is a plus b, and this is 1 1 1. So now you can see your column 1 and column 3 are equal. So value of this determinant will become 0. So this is 1 by 2 a plus b plus c into 0. This is equal to 0. So it implies that a, b, c are collinear. So applying the property is optional. If you want to apply a property, you apply. Otherwise you just open the determinant as you used to do in exercise 4.1. This is another question based on the area of triangle formula. Find the values. I have underlined this word values of k if area of triangle is 4 square unit. Most of the time student do things in hurry that they find only one value, but here it is values. In that type of questions you will always get two values. So that how it is to be done, now I am going to do. So area will be area of triangle. This is, we apply the formula directly. This is k, this is 4, this is 0, this is 0 0, and this is 2, this is 1 1 1. So you can see the area is given to us. This is 4 and here it is 1 by 2. So normally now you open this with the help of this 2. So this will be 2 into k. This position is plus, this is minus, so this is minus 2, and this becomes k into 1 k and minus 4. So you can see this 2 2, this is cancelled, so this is minus k minus 4, and this is 4. So now you will go in that case because you don't know what value of k is. So most of the time what you are supposed to do, you've done in class 10th also in this type of question, because you don't know the value of k. So and the area is always positive, so but you don't know what the value of k is, so you'll always take plus minus here. So if you take plus minus, then take one equation, this minus k plus 4, and second one minus 4 equal to minus k and plus 4. This so you solve this k will be 0 from this side, and this will be minus 8 equal to minus k, so k is 8. So therefore k are the values of k are 0 and 8. So this way you have to go always in these types of questions. Now come to this question number 4. Find the equation of a line joining 1, 2 and 3, 6 using determinant. So now you don't know that there is a line. So this is 1 comma 2, this is another point 3 comma 6, and you have to use the method of this determinant. So let assume one point from your side that x comma y is on this line. So now you can see all points are collinear. So area of this triangle will be 0. So it means 1 by 2, because all 3 points are now collinear. 1 x 3 2 y 6 1 1 1. So now this you put equal to 0. Now simply you open it or you apply the identity, it's up to you. So better you can open directly from this way. So this is 1 by 2 1, this is y minus 6, then minus 2, this is x minus 3, this is 1, and this is 6x minus 3y, and this is equals to 0. So this 1 by 2 will go this side, it becomes 0. So you open the bracket, 1 minus 6 minus 2x plus 6, this is 6x minus 3y, this is equal to 0 into 2, so it becomes 0. So y and this y, this becomes 2y, 2x, and this is 6x, so this becomes 4x. This is minus, this is plus 6 cancelled, and now this is 0. So ultimately your answer is this equal to 0. So you may simply you may write this is 2x minus y equals to 0. So this is your answer. Using the method of determinant, you have found the value of the equation of the line. The next concept is we are going to find minors and cofactors of the element of determinant. So rather than giving you the definition, I just going to show you how to calculate minors. So minors are actually for minors, as the positions are of these elements, their positions are also of minors. So let's say M11. M11 is the minor 1 position. Minor, how to find minor in 2 cross 2? Simply you see that you hide this column 1 and row 2. So column 1 and row 2, if you hide, this 3 is left. So that 3 is the minor 1. Now minor 1 2. Minor 1 2. Now again you do like this. Minor 1 2. This row 1 and this row 1 and this column 2 you hide. So this 0 is you can see that 0. That 0 is you can see it's visible now. So that M12 will be 0. Now M1, this is now M21. 21 you hide this way, you hide. So you can see this minus 4. So this minus 4 is your answer. M22. M22 will be this 2. So these are the minors. Now we'll find the cofactors. Cofactors in the NCERT book, it's written in the form of A11, but I am using C11. It symbolizes that these are the cofactors. Cofactors, the formula is minus 1 row plus column. Row plus column, here this row is 1, column is also 1, and this will be minor M11. So you can see that minor M11, the minus 1 is to power 1 plus 1, this is 2. So minus 1 is to power 2 means this becomes positive. So this will be M11. M11 we have already found, this is 3. Now next one is MC12. This C12 means minus 1, 1 plus 2. Row is 2, column is 3. So row plus column you do and write M12. So again this becomes minus because power is minus 1 is power is odd and 1 2 value is 0. So this is minus 0, ultimately you may write as 0. Next is C21 minus 1 2 plus 1 M21. So minus 1 is again means this is odd power, so it becomes negative, and minus 2 1 is minus 4. So this is minus 1 and this is minus 4. So ultimately answer is 4, or you may say, you may write here now as 4. Now last one is C22 minus 1 2 plus 2. Always you have to do like this, whether it is a 2 cross 2 or 3 cross 3 matrix. So this is minus 1 2 plus 2 and this will be M22. So this will be your M22 is 2 and this becomes positive, so this is plus 2. So this is your cofactors. Now we'll come to the cofactors and minors of these elements. But here you see minors and cofactors, you know, will be have a very big list. So I'm doing few for you, rest you will be finding yourself. So now M11 is as you were doing earlier. Now row 1 you hide and column 1 you hide. So your entries, now you can see this is 5 2 and 1 minus 1. You open this determinant, so 5 into 2 10 and minus minus plus 1, so it will be 11. So I'm writing this M11 as 11. Now M12 you again do like this. Will hide this and this. Now you can see which elements you can see. So elements which are visible now, this is 3 0 and minus 1 2. So 3 into 2 this is 6 and 0 into this, so 0 it will be. So answer will be 6. Next one is M13. M13 you again now do like this. M13, this is 3 into 1 and 0 into 5, so this is 3. M22 you come, M21 you come. M21 means row 2 column 1. So now we do you see this, you hide this one, so it will be 0 into 2 0 and this is minus 4. So this becomes minus 4. M22, this 5 ke along karna, so better you hide this and second this column. So this will be 1 into 2 and 0 into 4, so this will be 2. M123, M23 this along this you do, so this becomes 1 and this is 0, so this is 1. Next you come to M31. M31 you hide column 3 and you hide row 1. So you can see the entries are 0 5 4 minus 1. Cross multiply them. 0 into this is 0 and this is minus 20. So answer will be minus 20. M32. M32 is you hide this way. So this is 1 3 and 4 minus 1. So minus 1 minus 1, this is minus 1 and minus 12. So minus 1 and minus 12 is minus 13. Last is M33. M33 you simply do like this. 1 5 ja 5 and this 3 0. So this is 5. So we have found all the minors. Now cofactors. We'll write first few, will write in the formula. After this you may write directly. So C11, this is minus 1 1 plus 1 and M11. So you can see this minus 1 is to power, this is even, so it becomes plus. So M11 is 11, so answer of this cofactor is also 11. Now similarly C12 minus 1 is to power 1 plus 2 and minor 1 2. Minor 1 2 is 6 and this becomes minus 1 is 1 plus 2, this is negative and this is 6, so answer will be minus 6. Now C13 will be minus 1 1 plus 3 M13. So this will be minus, this 1 3 is 3 and this becomes positive because power is now even. So your answer will be 3. Now come to C21. C21 you can now see this is odd. So this is odd, and minus 1 is to power odd will be 2 plus 1 is odd. So minus 1 is, and this is negative, and this is M21 is minus 4. So minus 4, so it becomes plus 4. C22. C22 will be plus position, and so M22 is 2, so it becomes 2. And next you can find C23 also here. C23 is negative position, and C23 is this minus 1, so it will be minus 1. Come to C31. C31, this is negative position or positive position. 3 plus 1 is positive, so I am just writing this minus 1, 3 plus 1, and this is M31. So M31 is minus 20, and this becomes minus 20. Now C32. C32 is negative because 3 plus 2 is odd. So 32 is minus 13, so it becomes plus 13. Last is C33. This is positive because 3 plus 3 is even, and 3 is 5, so it remains 5. So we have found all the cofactors and minors of this determinant. Now I am taking question number 3. Using cofactors of elements of second row, evaluate this determinant. So first we'll find the cofactors of second row. Second row means C21. We'll first find this is minus 1, 2 plus 1, and this is minus 2, 1. So minus 2, 1 we now calculate. Minus 2, 1 is this. So this will be, this goes, 3 3 are 9, and 2 is 16. So 9, this is negative, and this is 9 minus 16. So this is 7 minus 7, and this becomes plus 7. Now we'll calculate C22. C22 will be minus 1, 2 plus 2, C22. So this is M22. So this is plus position. C22 is this. So this goes, 5 3 are 15, and 8. So 15 minus 8, this is now 7. So it remains plus 7. C23. C23 is minus 1, 2 plus 3, M23. So M23 is this, you hide. So 5 2 are 10 minus 3. And this is the negative position, so it becomes negative. So this is now minus 7. Now value of the determinant, let's say this is determinant A. So determinant's value will be, see the cofactors I have found for second row, and if I do like A21, so this is the element of second row, first element. So multiply with C21. Similarly A22 you multiply with C22, A23, C23. So if you do like this, your value first is 2, then this is 0, and this is 1. C21 is 7. This is into 7, and this is minus 7. So this is 14 minus 7. Answer is 7. So very important result. Result is that if you multiply the corresponding elements of the cofactors, then your value of the determinant will be calculated. So this way you can do the calculation with any row, with any column, your answer will be same. So remember this important thing. But there is another result, and it is there in the NCERT also. If I take the element of any other row, for example, if I take here A11, here I take A12, here I take A13, then answer of this determinant, whatever the value of this will be 0. That will not be the determinant, but the value of this expression will become 0. So remember this important result. If you multiply the cofactors with the corresponding elements of the determinant, then your answer will be the value of the determinant. But if you multiply cofactors with any other row, then your answer will be 0 always. You can verify, or this is there also in the NCERT. You can see the example. Now we'll understand very important thing of this chapter, the adjoint of a matrix. I have written here something. Adjoint of A means any given matrix, then you write the cofactors in this order, and you take the transpose. So whatever comes, that will be your adjoint of the given matrix. So rather than giving you the definition, I have given you the symbolic form. So we'll do one example, and after this you will come to know what is adjoint, and after this we'll discuss these three very important results. So now come to this question number, this is the first question. Find in, this is one of the question of exercise 4.5. So first we'll find cofactors. C11 we are calculating now. C11 is minus 1, 1 plus 1, and minor 1 1, minor 1 1. So this is plus 1, minor 1 1. So minor 1 1 is 3 into minus this, minus 3. So this becomes minus 3. You can show these calculations in first two cofactors. After this you may write it directly. Then this is C12. This is minus 1, 2 plus 1. So this is minor M12. So this is negative position 1 2. This is minor 1 2. So you hide this 3 minus 3 and this 0. So minus 3. So this is minus and minus 3. So it becomes plus 3. Now after explaining you this in detail, I'm finding the cofactors now directly. 1 3. 1 3 is a positive position. So this becomes positive M13. M13 will be this 6 and 15. 6 minus 15. So this is minus 9. Then come to C21. C21, this is the negative position. So write negative, and this. So this will be 0 and this is 0. So this is 0 ultimately. Now C22 you calculate. C22 will be this. This is a positive position. So write plus. This goes minus 1 and this is 0. So minus 1. So this answer is minus 1. Next is C23. C23 is this is position, this multiply. So 1 2 is 2 and this is 2 and this minus 2 because this sum is odd. Now come to last row, C31. C31 is this is a positive, sum is even. So this is 0 into 0. So answer is 0. C32. C32 is this, you hide 1 0 and 3 0. So ultimately this answer is also 0. C33. So C33 is this is a even position. So this you can calculate now, 1 into 3 and this. So this is 3. So we have calculated all the cofactors. Now we'll write adjoint of A as, and always write the cofactors in some order so that you can directly put into the matrix. It will be easy if you put into the matrix in that order, otherwise you might get confused kaun si value kahan dalni hai. So do something in a order. So this is minus 3, 1 2 is 3, and this is then minus 9, and this is 0, this is minus 1, this is minus 2, this is 0 0, and this is 3. So you put transpose. So final answer will be minus 3 3 minus 9 0 minus 1 minus 2. This is 0 0 3. So this is your adjoint of A. Now move to these three results. The result proof I am not giving now, but you may ask or we may discuss in our next classes. But you remember the results, that A into adjoint of A, these are very important. Always 1 mark question come on the basis of this. So please take this very seriously and always do some questions basis on this other than the questions given in the NCERT. A into adjoint of A equal to adjoint of A is determinant of AI. A is a matrix, adjoint of A is a matrix, so the answer should be matrix. So A is some constant value and this I is the identity matrix. So answer is this. Second result is that determinant of AB is determinant of A, determinant of B. Or in general, one more result, that this result was asked in the CBSE exam for 1 mark, that adjoint of A determinant is always determinant of A n minus 1. That proof can be given very easily. The proof is there in the NCERT also, but that theorem's proof never asked in the exams. So theorem 4 is now saying that a square matrix A is invertible matrix invertible if and only if A is non-singular matrix. Non-singular matrix means that determinant of A, you can say that determinant of A, if it is not equal to 0, then it is called singular matrix. So we'll discuss more questions basis on this. Now we'll move further after this.